Okay, I'm going to do a video for difference of squares intro and difference of squares. Okay, so the example that I pulled up on Khan looks like this. And it's saying what expression represents the width. So if this is a square, then the tiles are going to make a square. I have x squared and I have negative 25. So what would make a square here? Well, I know this is x and times x, and I know for this to be negative 25, it's got to be positive 5 and negative 5. So this is going to factor into x plus 5 times x minus 5. So the answer would just be x minus 5 because it's only asking for the width of the, it says rectangle, but it's actually a square. Okay. Also there is, turn that down a little. Okay, and then the next example I get says 25 minus x squared equals what? Well, this is almost the same thing as what we just did. There is a poster on the board for difference of two squares, and at the bottom it says u squared minus w squared equals u plus w times u minus w. And when I was coaching a lot of you in class, I would just say if u squared is 25, what's u? And most of you would guess or choose 5 correctly. If w squared is x squared, what's w? Well, that's, whoops, got to be x. So then this would factor into 5 plus x, 5 minus x. Okay, moving on to difference of squares. You're going to be factoring out a common factor and basically doing the same thing. So I'm looking at an example that says 2x squared minus 162, and I'm supposed to factor it completely. Now I could do area diamond with this. It is possible, but it's much easier if I factor out the common factor. So I'm going to take out the common factor, which on Khan I have not seen one where it's different from this. It's always the leading coefficient, the coefficient of x squared. I don't want you to think it's always going to be like that, but on Khan it is. So 2 times x squared is 2x squared. 2 times 81 is 162. So I factored out the common factor of 2, and then this is in the form u squared minus w squared. If I built, or even if you just do a model with x squared and 81, you'll be able to see, oh, that's got to be x plus 9 and x minus 9, right? I mean, you could do area diamond, but it's almost easier to just guess what this should be and then see if it works using an area model. So then this would factor into 2 times x plus 9 times x minus 9. Okay, the next example is actually just a difference of two squares. There is no common factor. There's nothing that goes into 16 and 81. So I'm just going to factor this out using this template right here. U squared minus w squared equals u plus w times u minus w. So if u squared is 16x squared, what's u for x? If w squared is 81, what's w? 9. So this is going to be 4x plus 9, 4x minus 9. Is that correct? Okay. Okay, if I did 4x plus 9 and 4x minus 9 for the length and the width, that would give me 4x squared, or 16x squared here. It would give me negative 81 here. It would give me 36x here. It would give me negative 36x here. These would cancel out. So that's the reason this only works for a difference of two squares. If this had been a plus sign, then those two terms wouldn't cancel each other out. You have to have a positive times a negative right here. Okay, that should get you through difference of two squares.